welcome back to another Topic 5 HL video where we will be looking at evaluating limits. Now in this video, we'll be understanding how to evaluate a limit, understanding what the difference between left and right limits are, and becoming aware of indeterminate forms. Now first, to evaluate a limit. The limit notation is actually pretty special because it allows us to calculate the value of our function at a specific x value, which we normally would not be able to plug in. So whether that's an undefined value, whether that's something like infinity, right? It's also useful just to calculate the value of a function at a point, right? So therefore, because we're just evaluating a y value, we just have to basically plug in some x value into the function to calculate the value of this limit. Let's look at two examples. So the first example, we have the limit as x approaches 4 of this quadratic function. So we're trying to find the value of this function as x gets infinitely close to 4. So effectively, we can just plug in 4 in for all of the x's in this function. And if you were to calculate this, you would end up getting 21. So 21 would be the value of this limit. In the second example, we can also find limits for values like infinity. So we have the limit as x approaches infinity of this rational function here. Now what you can do just like before is plug in infinities. Now you can't like normally plug in infinity into a question because it's not a defined value. However, the limits helps us to be able to like approximate and view patterns that would happen with infinity instead of actually calculating the value. Now, if we're trying to simplify and calculate what the value of this limit would be, that +8 and that -7 there are negligible changes that are happening to infinity. So if we think about an infinitely large number, if we try to add 8 to it or take away 7 to it, those numbers are going to have no effect on how infinitely large this number actually is. So therefore, we can kind of disregard those two numbers when it comes to simplifying, and we're left with just 2 infinity over infinity. Now we'll see shortly, we can't really take infinity divided by infinity, but if we just observe the pattern that is happening, we can find the ratio between these, and we can say basically the ratio between these would be 2. 2 infinity over 1 infinity, so the ratio between them is 2. So that would be the value of the limit. Another concept to be aware of is left and right limits. So some limits have different values depending on the direction which they are approaching the x value. So take that first limit on the top right, the limit as x approaches to negative or minus. That means that x is approaching to coming from negative x values. In other words, it's coming from the left. So if we look on our graph there, for coming from the left-hand side, from negative x's up to 2, the value of this function, the limit of this function is going to be 3. However, if we look at the limit below, the limit as x approaches 2 with that plus sign there, that means that x is coming from the positive direction, or in other words, from the right. So the limit as x approaches 2 from the right wouldn't be 3 anymore, it's now 7. So we can have different limits depending on the direction in which it comes from. And I also just want to make you aware of a slight problem that we might run into when we're trying to solve limits. So let's take this following limit as an example. So we have the limit as x approaches 0 of sine x over x. Now, if we follow the same strategy we've been doing, we'd basically want to plug in 0 for x. If we do so, we get sine 0 over 0, which if we simplify using our trig rules, we'll end up getting 0 over 0. Think for a second why 0 over 0 might be a problem. Well, it's actually because it is like a number written in indeterminate form. And something in indeterminate form means you can't actually determine, you can't calculate what the value of this is. We don't have enough information about it. Like it doesn't really exist as something, right? We might run into other indeterminate forms as well. So 0 over 0 is one, but another common one we might see is infinity over infinity. So we can't actually calculate the value specifically of what that limit would be. We have ways in which we overcome this problem that is in the HL course that will be in future videos, but the worksheet below will kind of allow you to investigate and think about these indeterminate forms before we go into that. So let's practice, do the worksheet below, share your answers in the comments, compare with other students, and ask your questions, and I will see you for the next video.